I will discuss the non-preemptive shortest job first scheduling algorithm. First, I will discuss what is the non-preemptive shortest job first scheduling, or the SJF. The second one is the characteristic of SJF algorithm. The next one, or the third one, is the drawbacks of non-preemptive shortest job first scheduling. First, what is the non-preemptive shortest job first scheduling, or the SJF? Shortest job first is another type of scheduling technique in which the process with the shortest burst time is given to the CPU first for execution. SJF scheduling is a non-preemptive scheduling technique. Okay, what is a non-preemptive? If a process gets CPU, then executes for the given burst time and no process can be preempted. This should be the shortest burst time, and then no another process should be inserted using the non-preemptive. The second one is the characteristic of SJF algorithm. The average waiting time by using the SJF is less than the first come first serve algorithm. Since the process with the shortest burst time execute first, since the turnaround time is also short by using the SJF. SJF gives an improved output by selecting a short-term job first to execute. Next, this is the scheduling technique. It's useful for batch time processing, and where waiting for the jobs to complete, it is not critical. Okay, this is much better than the first come first serve, because he will get the what should be the lowest or the shortest burst time should be the first process to be executed. Okay, the next one is the drawback of non-preemptive shortest job first scheduling. One drawback of the SJF is the non-preemptive version is if all processes arrive in ready queue at different time, then there might be a chance that a process with a short burst time have to wait for the current process execution to finish. This is because when a process with a shorter burst time comes, then the existing job is stopped to execute and the shortest process is given to the CPU. It means that when there is an existing process, uh, then with a greater burst time, and then another process comes in with a lesser burst time. The lesser burst time should be come first or to be executed. This can be lead to a serious problem also known as starvations. That is a process and never getting executed because every time a process with a shorter burst time comes and obstruct this process to get the CPU. To resolve the problem, we have a concept of aging. In aging was assigned a priority to each process, and this priority is increase the process is starved more and more. Then after some time interval, we check the priority of the process, and the process with the highest priority is given CPU. Okay, this one, when ever there is a process for with the shortest burst time, okay, and then the other process will be other inserted must greater burst time. The first lowest or the lowest burst time should be executed in the process. Okay, next I will show you a sample simulator. Okay, okay, this is a CPU sim scheduler simulator using the Java. Okay, this is the process 1, process 2, process 3, 4, and 5. Okay, this is the given. Arrival time. ET is for stands for arrival time. Then BT stands for burst time. WT stands for waiting time and turnaround time. Okay, this one, this is given. Then we'll solve for this one for the waiting time and the turnaround time. And then the Gantt chart also will solve this one. Okay, how to come up with this one. And then the average waiting time and the turnaround time. Okay, for the detail for this one, I will use another application for the Excel. Sorry. Okay, this is same input as I shown before, the simulator of Java. Then we'll solve for the Gantt chart first. Okay, first, the arrival time for this one, if we look at this one, uh, P1 has a 0 arrival time. Okay, let's put P1. Then the burst time is 4. Okay. Okay, we will put temporary for this one. Next, we'll mark as done using this one. Okay, if we're comparing the burst time from P2 to P5, okay, what should be the lowest? Okay, this P3 should be the lowest burst time. Okay, well, next, for the process P3, and then the arrival time for P3 is P3 is 2. The burst time of P3 is 1. Okay, this is the graphical representation for the Gantt chart. Okay. Okay, this one. Okay, for the P3, okay, how P3 come up with the completion time of 5? Okay, kindly add 4 plus 1. This 1. And then this one. To come up with 5 for the completion time. Next, we'll mark as done. We'll compare P2, P4, and P5. Okay, what should be the lowest burst time? Okay, the lowest burst time is P2. Oh no, P4. P4 with arrival time of P3. No, arrival time of 3. And a burst time of 2. Okay, how to come up with this one? For the completion time of P4 should be 5 plus 2, 7. Next, it's done. Next one is P2. Okay, with an arrival time of 1 and a burst time of 3. 7 plus 3 is 10. This is number 10 for the P2. Okay, the last one is mark as done. First, P5. P5 with a arrival time of 4 and a burst time of 6. 10 plus 6 is 16. Okay, that one. Okay, to come up with the Gantt chart, compare this for the Gantt chart, okay, the P1 with a starting time of 0 with a completion time of 4, P3 with a starting time of 4 and the completion time of 5, P4 with a starting time of 5 with a completion time of 7, P2 with the starting time of 7 then completion time of 10, then P5 is a completion starting time of 10 then completion time of 16. Okay, next, we'll solve for the WT. WT is a waiting time. To solve that one, starting time minus arrival time is waiting time. The starting time for P1 is 0. Arrival time for P1 is 0. Starting time for P2 is 7. Arrival time for P2 is 1. Starting time for P3 is 4. Arrival time for P3 is 2. Starting time for P4 is 5. Arrival time for P4 is 3. Starting time for P5 is 10. Arrival time for P5 is 4. Okay, to get the average waiting time, add process 1 up to 5 and divide by 5. Or you can use the average for this one formula. Okay, next, we'll proceed to the turnaround time. Okay, before we proceed to turnaround time, the answer for the waiting time is 1 and this one is the same. Okay, to solve for the turnaround time, completion time minus arrival time, that is turnaround time. P1, completion time is 4, arrival time is 0. For P2, completion time is 10, arrival time is 1. For P3, completion time is 5, arrival time is 2. For P4, completion time is 7, arrival time is 3. For P5, completion time is 16, arrival time is 4. Okay, this one. Okay, this is the waiting time, then turnaround time. Okay, this is I'll show you the simulator if we have the same answer for that one. Okay, this is the Gantt chart. This one for the simulator. Okay, this is the waiting time. Okay, this is the turnaround time. And then this is the average waiting time, which is 3.2, and the average turnaround time is 6.4. Okay, that's all for the SJF, or the shortest job first algorithm. Thank you for watching this one.